Hello and welcome to the EPRI Current. I'm your host, Samantha Gilman, and today we'll be talking about extreme heat, climate data, modeling, and forecasting for energy system resilience. I'm joined by Erik Smith, a climate resilience analyst, and Dan Kirk-Davidoff, who is an atmospheric scientist and a senior technical leader, both of which are in EPRI's Energy Systems and Climate Analysis Group. Thank you for joining me so much, guys. Erik, briefly tell us a bit about what you do here at EPRI.
Yeah, thanks, Samantha. So climate resilience analyst at EPRI. So what that means is I stay on top of the current state of the science in regards to climate extremes, like these past extreme heat events, trying to understand how those are changing and going to change in the future, because that has major implications on the power sector. I tackle a lot of questions around resource adequacy and system reliability across the grid, and spend a whole lot of time thinking about climate data.
Great. And Dan, tell us a little bit about what you do at EPRI.
Thanks, Samantha, and thanks so much for having us on. I've been at EPRI about a year, and I work a lot on understanding how our electrical system will work in the future when it's much more heavily dependent on renewable generation, and also has a lot of different kinds of electrical demand placed on it than maybe it has in the past.
Great. Well, let's dig into that a little bit. Erik, can you tell our listeners a little bit more about the climate analysis work that EPRI is engaged in?
Yeah, absolutely. So we do a lot of work on system reliability and resource adequacy. So system reliability, we're thinking a lot about like extreme weather, so extreme heat, extreme cold, heavy precipitation, high winds, tornadoes, hurricanes. There's a lot of hazards to the power sector, and we want to make sure we have an understanding of how those have changed in the past and how they might change in the future. So we also are leading a lot of research across the power sector and really across the globe. So we have a big climate ready initiative where EPRI is convening global thought leaders, scientific researchers. So we're working with folks from universities, national labs, institutes across the globe, and we're building toward a more informed and consistent, power sector. So we're trying to use climate data to really make informed decisions. And there's a lot of effort and a lot of research that's going into that through our Climate Ready initiative to help make these better decisions and know how to better use climate data going forward.
And that's great that you mentioned Climate Ready. We actually did an episode on Climate Ready a while back. So I encourage our listeners to go back and listen to, I believe, episode 2 with Morgan Scott, who leads Climate Ready, and Andrea Stade. Now, Dan, one of the things that Erik was sort of alluding to was also resource adequacy and load forecasting. Could you tell us a little bit about that work within EPRI's portfolio?
Resource adequacy is a concept that's really important in how people plan the next couple of years of an electric system. So electric power companies usually, like every year or so, and grid operators also will go through a process of assessing whether they have the generation resources to meet what will likely be the most extreme demand that they'll face over the coming year. And if they have enough generation resources, then they have adequate resources. So they have resource adequacy has been established. So the process of deciding whether you've got adequate resources has changed, just a little bit as we've added all these renewable generations to our portfolio. So one thing that people have been asking questions about, for example, is if we build, as we build gigawatts of offshore wind capacity off of New York and New Jersey and New England, those are all going to perform essentially as like one big wind farm because the wind is pretty well correlated over that area. And in the past, people have kind of assumed that the variability of a power plant's ability to produce power would all behave independently. So if you had two different plants, the chances of them both going out at the exact same time wouldn't be very likely. So we just have to think a little bit differently about how we're going to assess how much power will be available and we'll be confident will be available for us at times of extreme demand.
So sort of tying in this research that EPRI is working on that you both just went through and the current news of the day, it seems like every time I turn on the news these days, we're learning about a new heat wave, a new record temperature this summer. And so, Erik, can you speak a bit to this extreme heat that we seem to be experiencing across the US and really across the globe?
Yeah, it's definitely been hot in places, which is usual for the summer. There are heat waves in the summer. That happens every summer. I think that really the big question is about how extreme is this heat relative to, historical extremes, and then we certainly want to be thinking about how that's going to be changing in the future. But this summer across the U.S. especially has not been that hot. So when you look at the media headlines, you would think that it's been the hottest summer ever. But really, the heat has been confined to like Texas. So in June, Texas had some pretty consistent long duration heat events. That's shifted a bit more to now California, Arizona, New Mexico, Louisiana, down through Florida. So there's a lot more extreme heat across the South in July, across the southern U.S. But by and large, the U.S. is running about average as a whole. But also across the globe, there's a lot of heat records, so extreme heat records that have been broken. Rome shattered its all-time highest temperature. China shattered its all-time highest temperature with 126 degrees Fahrenheit a few weeks ago. Key Largo, Florida, so sea surface temperatures, not just land surface temperatures. Key Largo, Florida registered the warmest sea surface temperature on record at 101 degrees Fahrenheit. So it's like a hot tub down in Florida. That still has to undergo review by NOAA, but it's definitely shocking to see those kind of temperatures for ocean surface temperatures. Coming back to some of the records in the U.S., so while we haven't broken a lot of all-time daily high temperature records at some of the major cities like Phoenix, some interesting records have fallen, or duration of events. So Phoenix has had 26 consecutive days above 110 degrees Fahrenheit. But beyond that, nighttime temperatures have also been really extremely hot. So you don't get that reprieve at night like you would expect in the desert. So Phoenix, for instance, has had 16 consecutive days above 90 degrees Fahrenheit. Many of those days have barely dropped below 100 degrees Fahrenheit. So the air conditioner load is really plugging hard at night. And a lot of folks aren't able to relax at night like you would hope. And that it takes a big toll on the body. So tons of records across the globe, but maybe to summarize, the U.S. isn't running all that warm or above average as a whole.
Yeah, as Erik was saying, the temperature of the U.S. as a whole hasn't been much above normal, and that's because while it's been very hot in the south and southwest, and sometimes in the southeast, and also actually up in northern Maine, the middle part of the country, from North Dakota on down, has been quite cool this summer. So that draws our attention to the distinction between weather and climate. What are the kinds of things that we can predict because the world is getting warmer? And what are the kinds of things that are just always unknown about a summer coming up? Is it going to be hot or cold this summer in this place?
So, as we're talking about extreme heat and weather and extreme weather events, how is that affecting our energy system? And how is it coping with this hot summer? Dan, I'm going to turn it over to you first.
Yeah, we've been coping pretty well by and large. Haven't been a lot of reports of outages. A couple of the big grids got pretty close to resource adequacy thresholds. Texas back in early July had a few days where they were within a gigawatt or two of needing to ask people to reduce their consumption. But in a lot of parts in the country, we've been building just huge amounts of renewable resources in the last few years. So there's just there's often approaching 30 gigawatts of wind power potentially available in Texas, and approaching 20 gigawatts of solar power available. California also has order of 20 or so gigawatts of solar power available in the middle of the day, and that takes a lot of pressure off the rest of the system. So by and large, our grids have been behaving themselves this summer, despite some very high temperatures.
And back to our previous comments, we were talking about the modeling work and analysis that EPRI is working on. Were these high July temperatures something that had been forecasted by the seasonal models?
Yeah, it's a good question. It depends on what scale you're looking at. So, the planet as a whole is very hot. And that's because we're just warming because of people emitting carbon dioxide and methane and nitrous oxide over the last century. So every year is warmer and warmer. But then on top of that, we have these natural oscillations that go back by a couple of fractions of a degree every year, driven by sloshing back and forth of big amounts of water and heat in the Pacific Ocean. That's the El Nino variability. So basically, whenever there's a strong El Nino, those are the years when, globally speaking, we're going to set a record high temperature because every year gets a little bit warmer in the long run, and then the particularly warm years are the ones where we have an El Nino, and we've just been moving into an El Nino this year. So that usually doesn't have a whole lot of influence on temperatures in the US. So we weren't expecting a particularly warm summer. And as Erik said, averaged over the US, it hasn't been a particularly warm summer. The interesting thing is how predictable these heat waves across the South have been. And the answer is, well, we're really good at forecasting weather about up to maybe 8 days a week in advance. But beyond that, weather is very hard to predict, and probably beyond about 2 or 3 weeks, it's impossible. So that's where you kind of see the real physical distinction between weather and climate. When we looked forward into July from like mid-June, some of the things that we've seen in July have shown up. It was very warm in Canada, and that was predicted, and it was warm in Texas, and that was predicted. But it's also been super warm in Arizona, and that didn't show up in the long-term forecast. And what that tells you is that that's not something that's controlled by the things that are sort of stable and slow about the system, like the ocean, but it's controlled by weather variability, by high pressure areas and where the wind is blowing from. And those things can always result in extreme weather that's hard to predict in advance.
To that topic of the El Nino, Erik, can you tell us a bit about how the El Nino may impact temperatures this year?
Yeah, we get a lot of questions about El Nino, specifically how El Nino is impacting summer temperatures. There's a lot more research and a lot of maps that will show you how El Nino or ENSO impacts winter temperatures, but not necessarily summer temperatures, because El Nino typically impacts winter temperatures a lot more, and it impacts more regions. But El Nino in the summer, in the US especially, tends to actually limit extreme heat. So there's a lot fewer extreme heat events in the US, especially the eastern US. Um, the average temperature tends to be near average or even cooler across a lot of the western US and central US. So El Nino does have an impact on summer temperatures. As Dan said, though, globally, El Nino tends to force a lot more extreme heat. So global temperatures tend to average out to be quite a bit above average during El Nino events. And it's really important to understand, though, that El Nino impacts regions differently. And as you start to get further away from the center of action, which is the equatorial Pacific, so off the coast of South America and Peru, the impacts tend to be limited as you get further away. So like Europe, Eurasia, those impacts aren't quite as large as they are for South America or the Caribbean or the US or Australia.
And a quick question, because I'm wondering, and if I'm wondering, our listeners are probably wondering, when when exactly is El Nino? Has El Nino already started? Is it only during the winter? When is it?
Yeah, El Nino, they usually define it as when temperatures get above about half a degree above normal in a particular region in the Central Pacific. And we passed that a few months ago. We're up about a degree
Okay.
above normal. So we're definitely in an El Nino now.
Well, right in
There's
the
about
middle of it.
kind of a 3 year, no, kind of just at the beginning. It's supposed to peak around the early winter at maybe 1.8 degrees, which would be a pretty strong El Nino, about the third strongest that anyone who's been paying attention will have remembered from the last like 30, 40 years. The other thing to talk about with El Nino, and that El Nino influences really strongly, is precipitation. One of the reasons that California has had a really easy summer from an electric power point of view is that they had so much snow last winter. And that means that the reservoirs are now pretty close to climatological average, which hasn't been true for years and years and years. And so that means there's a lot of water available to power hydro plants, and they don't have to worry about borrowing from other folks. We've also seen, as is kind of characteristic of a warming planet, a lot of really dramatic precipitation events this summer, particularly in the Northeast and in eastern Colorado, where there have been some pretty extreme precipitation events.
So, as we're forecasting for the future to prepare our energy system for any extreme weather events, what does this year's weather and the upcoming El Nino teach us for those future forecasts?
As we move into the future, we're always wondering what we can learn about the weather that will tell us about how climate is changing. Climate, after all, is just the average of weather. And we have a lot of climate data these days. So, what we expect from year to year is that the weather should be within some range defined by our experience of the past. But because our experience of the past nowadays, for the last 50 years or so, includes a warming trend, we can't just say, well, the average temperature of the last 30 years was X, and so we expect this summer to be close to X plus or minus, some standard deviation. We have to adjust what we expect for this summer for the fact that like the last 10 years have been warmer than the 10 and years before that and the 10 years before that. And every time we have a new extreme, especially if you average over a pretty big area, that gives you additional information about what the trend is, and so how much warmer things will be going forward. So, what we can learn from this summer is that the globe is warming up, pretty much on schedule with what the climate models have been saying. And the extreme temperatures that we've experienced, that it's kind of interesting because averaged over the US, they haven't been all that extreme, but in some places they have been. And that gets to kind of the cutting edges of climate sciences, understanding what the impact of global warming will be on particular locations. And because, the temperature in one place is always a lot more variable than it is when you average over big areas, it just takes more data and it takes more time. And so there's more uncertainty in understanding what the role of global change is on temperatures in one spot.
Yeah, so we've got to start to think and plan for some of these extreme events. And we can't just keep our eyes focused on the historical data. We have to start to bring in climate model projections. So climate models provide data that we don't have, and they provide insights into possible futures that we can't understand from just looking at our limited historical data sets. So we have to definitely be planning for extremes beyond what we've seen in the past. And we, especially at EPRI, leverage a lot of climate models to think about how future extremes can impact reliability, resource adequacy.
Erik, that was a great way of putting it, so that we can see as we are forecasting or looking ahead how those forecasts could help us prepare the energy system both for reliability and resource adequacy. That was a really great conversation overall. I really appreciate both of you joining me today on the EPRI Current to talk about extreme heat forecasting and impacts to our energy systems. As always, we appreciate our listeners listening in, and you can listen to more podcasts from the EPRI Current anywhere you find your podcast, whether it be Spotify, Apple, or YouTube. And we'll talk to you next time. Thanks, everyone. Thanks, Erik. Thanks, Dan.
If you like today's show, we invite you to subscribe to our podcast. And feel free to share the podcast with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and Twitter at EPRI News. Together, we are shaping the future of energy.